Now that we have generated all of the sums of squares, we'll complete the analysis of variance. The next step will be to put in the degrees of freedom for each of the sums of squares so that we can calculate mean squares where necessary. The sums of squares between people has degrees of freedom equal to the number of people minus 1. So this is equal to 12 minus 1, or 11 degrees of freedom. The sums of squares within people is equal to the number of observations for each person minus 1 times the number of people. The number of observations are 3, so this will be equal to 3 minus 1 times 12, and we need to put parentheses around the 3 minus 1 for 24 degrees of freedom within people. The degrees of freedom for admissions is equal to the number of admissions for each person minus 1, which is again equal to 3 minus 1, or 2 degrees of freedom for admissions. The degrees of freedom for the residual is essentially 24 minus 2, but it can be thought of as degrees of freedom for people minus 1 times degrees of freedom for admissions minus 1. So that will be equal to 12 minus 1 times 3 minus 1. Or 22 degrees of freedom. The degrees of freedom in the total, finally, is equal to the number of admissions times the number of people minus 1. This will be equal to 12 times 3 minus 1, or 35 degrees of freedom. The degrees of freedom between people and the degrees of freedom within people must add to the total degrees of freedom. Next, we will find the mean square values, which will be used in the computation of the f-test. We could find mean squares for sums of squares between, sums of squares within, sums of squares total, but none of these are of particular interest. All we're really interested in this case is the mean square for admissions and the mean square for the residual. These will make up the f-test. So the mean square for admissions is the sums of squares for admissions divided by 2, and the mean square residual is sums of squares residual divided by 22. These are the two values which will make up the f-test. The f-test is equal to the mean square for admissions divided by the mean square residual, and it comes out to be 3.6. Now finally, the probability of that f will be equal to f dist the value of f, 2 degrees in the numerator, 22 degrees in the denominator. And the probability of that f is 0.04. This indicates then that we would reject the implicit null hypothesis that cost is independent of admission, and instead accept the alternative that says that cost is not independent.